Photoinitiators are crucial in various industrial processes. They initiate polymerization when exposed to ultraviolet or visible light. As environmental regulations continue to tighten, the demand for reducing volatile organic compound (VOC) emissions is on the rise. They allow for efficient curing with low energy consumption, and the initiation efficiency and material properties can be further enhanced by incorporating nanotechnology. Additionally, these photoinitiators can improve compatibility with a wide range of substrates and resin systems. The trend towards multifunctionalization will broaden their applications in coatings, inks, adhesives, and 3D printing, enhancing properties such as adhesion, durability, and antibacterial effectiveness. Particularly in 3D printing hydrogel materials, water-based photoinitiators hold significant potential due to their excellent biocompatibility, high water content, and adjustable mechanical properties. Water-based photoinitiators significantly reduce the environmental footprint of various manufacturing processes. Unlike their solvent-based counterparts, which release harmful volatile organic compounds into the atmosphere, water-based formulations utilize water as the primary solvent. This substitution dramatically reduces volatile organic compound emissions, contributing to cleaner air and a healthier environment. The reduced environmental impact of water-based photoinitiators aligns with the increasing global emphasis on sustainability. The use of water as a solvent also minimizes the risk of fire hazards associated with flammable solvents. This aspect enhances worker safety and reduces the likelihood of accidents in manufacturing facilities. Moreover, water-based photoinitiators often exhibit lower toxicity compared to solvent-based options. This characteristic translates to safer handling procedures and a reduced risk of adverse health effects for workers. Despite the shift towards environmentally friendly alternatives, performance remains a key consideration. Water-based photoinitiators are not only eco-friendly, but also exhibit excellent performance characteristics. They facilitate the creation of high-quality coatings, inks, and adhesives with desirable properties. These properties include durability, chemical resistance, and adhesion to various substrates. The versatility of water-based photoinitiators allows for their use in a wide range of applications. With their low volatility and low flammability, water-based photoinitiators offer greater safety during transportation, storage, and use. Their low odor is another advantage, making them suitable for applications where strong smells are undesirable, such as in food packaging or indoor environments. The absence of harsh solvents also contributes to a safer working environment for those handling these materials. This combination of high performance and reduced environmental impact makes water-based photoinitiators an attractive choice for manufacturers seeking sustainable solutions. In biomedical applications, such as 3D printed hydrogels and tissue engineering, water-based systems are more compatible with biological materials. This compatibility reduces cytotoxicity and enhances biocompatibility in these applications. Specifically in 3D printed hydrogels, water-based photoinitiators have a better ability to mix with polymer precursors. This improved mixing ensures a more uniform curing process during the printing of hydrogels. As a result, the material's structural stability is enhanced. Additionally, the performance consistency of the hydrogel is improved due to this uniform distribution and curing. Companies like Watson International are at the forefront of developing and manufacturing high-quality water-based photoinitiators. Their commitment to innovation and sustainability has resulted in a range of products that cater to diverse industrial needs. Watson's water-based photoinitiators are designed to meet the stringent requirements of various applications, ensuring optimal performance without compromising environmental responsibility. Their expertise in photochemistry and polymer science is evident in the superior quality and efficiency of their products. Watson International's commitment to sustainability extends beyond its products. The company places a strong emphasis on responsible manufacturing practices, minimizing waste generation and reducing its overall environmental footprint. This dedication to sustainability has earned them recognition and solidified their position as a leader in the field of water-based photoinitiators. The future of water-based photoinitiators is bright. Continued research will lead to more innovative applications. Research will lead to groundbreaking advancements and better patient outcomes. Recently, Watson has made a significant breakthrough by optimizing production processes and expanding capacity, successfully scaling up the production of LAP to the 100-kilogram level. This scale of production reduces unit costs, enabling Watson to offer the most competitive prices in the market. If you're interested in water-based photoinitiators, feel free to visit www.watson-int.com for more details, or send an email to photoinitiator@watson-int.com for inquiries.